So last week I started off by teaching you all the concept of special angles. So for special angles, you kind of need to remember the triangles that give rise to them. So for special angles in terms of degrees, we have 45 degrees, 30 degrees, and 60 degrees first. Okay. The triangles that give rise to them are a isosceles triangle like this. 1 square root 2. This must be 45 degrees. Or alternatively, you have an equilateral triangle of sides 2. Equilateral triangle, so this must be 60 degrees, and this is 30 degrees then. From these two triangles, you can infer sine, cosine, tangent, 30, 60, and 45 degrees. Okay. Then following which, we have a new set of measurements called radians. So this is degrees. For radians, the unit of measurement is such like, 180 degrees relates to pi. So 60 degrees must relate to pi on 3. 30 degrees must relate to pi on 6. 45 degrees relates to pi on 4, okay? And 360 degrees must be 2 pi then. You need to be versatile in both sets of measurements. For a first new learner, everybody will prefer to use degrees, but gradually you'll realize that everything shifts towards radians. It's the more professional unit of measurement for angles, okay? Which means that from now on, right, for degrees, you should actually write a small circle on top to indicate that you are accounting for degrees. Most of the time, as you will know, degrees has got much larger numbers than radians, right? Looking at the numbers, you should have a good sensing of whether it's degrees or radians regardless, okay? So this was the start, and I have no other, you have to find your own way of memorizing the special angles regardless, okay? So there's no way out of this, and there's no point trying to memorize this only at the day before exams. So following this, we move on to 3 new trig ratios, namely secant, cosecant, and cotangent. So these are the short form. Secant is known as 1 over cosine. Cosecant is 1 over sine. So please don't mix up between these two, secant and cosecant. It's the most common mistake. So cotangent can be seen as 1 over tangent or cosine over sine. Okay, depending on the situation, it will call for it, because tangent is simply sine over cosine. Okay, so 1 over tangent is thus cosine over sine then. So these are the 3 new trigo ratios, secant, cosecant, cotangent, that you need to be aware of. But practically speaking, they are still built up from sine, cosine, tangent. So you are not learning anything new meaningfully anyway. Okay. Then this was secant, cosecant, cotangent. Then after that, I taught the concept of basic angles. So basic angle is known as alpha. And the basic angle is always, okay, if I work with degrees, okay, it's always going to be an angle between 0 degrees to 90 degrees only. So basic angle is like the DNA or the basic building block of any given angle. So this concept allows us to extend the knowledge of trigonometry beyond 180 degrees already. So it's usually built on a compass that was this. You have an X, you have a Y, okay? So trigonometry's orientation is always beginning from the positive x-axis and moving in the anti-clockwise fashion. This will be what we call the positive orientation. So if we move from the positive x-axis in the anti-clockwise fashion, right, this will be the first quadrant that we touch upon. So it's called Q1, quadrant 1, not quarter 1. So quadrant 2, quadrant 3, and quadrant 4. So for the time being, we will just stay focused on one revolution only, one complete revolution. So that will be 360 degrees and encompassing 4 quadrants. But there will be more of this later on, at least for today, okay? So each individual quadrants, you have a different way of managing their special angles. I mean, their basic angles, sorry. So the mind map, the frame of picture is always like this. Basic angles are always branching out from the x-axis itself. So this guy is alpha, this guy is alpha. Okay, let me just look at the first 2 quadrants first to avoid convoluting the picture. Which means that an angle in the first quadrant, right, which is namely like this, theta 1. It itself is its basic angle, okay? Because this angle size is the same as this angle size. Okay, so in quadrant 1, theta is equal to alpha. Okay, alpha is the basic angle, theta is the angle of that we are actually studying, all right? In quadrant number 2, an angle will be like this, okay? So let's say this is 160 degrees. This angle here is the alpha, 20 degrees. So 20 degrees is the basic angle of 160 degrees, okay? So in Q2, right, the relationship between theta and alpha is as such, theta plus alpha is equal to 180 degrees. So from there, we can actually calculate alpha, given a Q2 angle. So, but before that, you also need to have a skill of understanding when is the angle Q1, Q2, Q3, Q4, right? So remember, this is 0 degrees, 90 degrees here, 180 degrees here, 270 degrees here, okay? So any angle between the two borders, it will be in Q2 then, okay? But let me just highlight again, a 90-degree angle is neither in Q1 nor Q2, okay? Because it's on the border right here. An angle of 180 degrees is neither Q2 or Q3 because it's in the border, on the border, I mean. So moving on to Q3, the picture gets messier now. In Q3, I will have the basic angle that's like this, alpha. So my angle will be like this big, okay? So you can see that this small little guy here is my alpha. So in the world of Q3, right, theta minus 180 is equals to alpha actually. Okay, so and then we have a Q4. In the world of Q4, this is theta and this is alpha. So in the world of Q4, 360 minus theta is equals to alpha. Okay, you are free to remember these four expression any way you like it. Okay, but based on the picture and based on what I'm seeing right now, I'm just remembering it this way. That's all. Okay. So I'm just going to erase this to avoid making it unreadable. So basically, what we only look at is just these 4 strokes. That's all. Okay. So just remember the basic angle is always derived from the x-axis. Okay. It's the gap between the angle and the x-axis. Not say gap. It's the linkage between the angle and the x-axis. That's all. Okay. So then from there we can construct. So from there, right, you are supposed to have the skills to understand, to identify, given a basic angle, right, you must understand who are the 4 quadrants that share who are the angles in the 4 quadrants that share the same basic angle throughout. So for example, if I say, oh, alpha is equal to 20 degrees, you must immediately be able to say Q1, Q2, Q3, Q4. If this is 20 degrees, this is 20, 160, 200, and 340 degrees. If I say alpha is equal to 50, then you must say 50, 130, 230, and 310 degrees right away. Okay, so you must be confident to do this, whether is it in degrees or radians. Sometimes even better, I will not give you alpha right away. I will give you the angle in question right away. So 165 degrees, for example. Then you are supposed to understand that 165 must be in Q2 because it's between 90 to 180. Then its alpha is actually 15 degrees, which means that Q1 is 15. This is 195 degrees. This is 345 degrees. Okay, but all these angles are important, yes, but the most important angles are once again the special angles. So you must identify the special angles that appear in the other quadrants beyond Q1. So the 30, 45, and 60 degrees I had at the start are mainly for Q1 only. So we obviously have them for other quadrants. So let's say alpha is 30 degrees. This must be 30 degrees, 150 degrees, 210 degrees, and 330 degrees. Okay, so you need to be very, very sensitive to these 4 numbers, at least for 30 degrees only. Then you have the 45 degrees, 45 degrees, 135 degrees, 225 degrees, 315 degrees. Okay, so they are like the 4 brothers that share the same DNA of 45 degrees. Then the last one must be 60 degrees. So we have 60 degrees, 120 degrees, 240 degrees, 300 degrees. Okay, so you need to memorize or be sensitive to these 12 numbers. Whenever they appear, you must have some special values or nice ratios popping out there. Okay, not very nice in a sense because some of them are square roots, right? But these are like universally accepted special angles. Okay, so this was the concept of basic angles first. Then after that, we move on again to develop something called ASTC. So what does it mean, right? It's back to the compass again. So the concept of basic angles, right, over here teaches you that they have the same DNA, but they are not exactly the same yet. Because 30 degrees is fundamentally not the same as 150 degrees, right? You have an extra angular displacement of 120 degrees. They are not exactly the same for sure, but yet they share some kind of similarity between them. So what do I mean by this, right? So let's just say in the world of Q1, based on your coordinate axis, this is a positive x and positive y situation. Q2 is negative x and positive y, okay? So if I have an angle in Q1 this way, so this will be theta 1. This will be y, this is x, okay, by your coordinate geometry interpretation. And this is what we call h then. And h is just square root of x squared plus y squared, which will always be a positive value. So you can see that if your x, y, and h are all positive value, your sine, cosine, tangent are just a ratio of any of the two sides at any one go, right? So for example, sine is y, sine will be, so sine theta is equal to y over h, which must be positive because both y and h are positive. Cosine theta is x over h, which must be positive also. And tangent theta is equal to y over x, which must be positive also. So all three ratios are positive. So the Q1 has got a short-term label of this guy, A. All trig ratios are positive. Okay, all trig ratios are positive here. So what will be the Q2 counterpart of this guy, right? The Q2 counterpart will be something like this. A congruent triangle, but flip the other way around, right? So this guy here, theta is equal to alpha, right? So its Q2 counterpart will be this guy, theta 2. Okay, so let's say theta is 10 degrees then. Theta 2 will be 170 degrees with a basic angle here of alpha also, right? And because the black triangle and the red triangle are congruent, so this guy will be y. This guy is now minus x. This guy is still h, positive h, okay? It's on the negative x because instead of x, because it's on the negative, it's on the left side of the Cartesian axis, the xy axis. So if you focus on the red triangle, you will realize that, and this is how trigonometry is defined. You cannot say, hey, how come theta 2 is being built on alpha? It's just part of the theoretical derivation. Okay, some wise old men in the past just say, let's go for this, and everyone went for this. So from here, right, sine theta is actually, or theta 2 to be precise, is actually, give me a minute, sorry, someone talking on the top. Okay, sorry, some delivery stuff. So sine theta over 2, right, will actually be y over h. And both y and h are positive, so sine theta 2 is positive. And you will realize that something starts to happen for cosine and tangent. Cosine theta over 2 is actually negative x over h, which must be positive, which must be negative, sorry. And tangent theta over 2 is equals to y over negative x, which will be negative, which means that in a concept of theta 2, only one trig ratio is positive, and that will be this guy here. Okay, so for angles in the second, and theta 2, just now I said is 170 degrees, right? But it could have been any generic angle in the second quadrant, actually. So theta 2, right, in the concept of second quadrant, only sine is positive, hence it has a short form, aka S. Okay, only sine is positive. So we can carry on the derivation, and then in the world of Q3, this guy here is your alpha, and this guy here is your theta 3, right? It has a negative x and a negative y now because it's on the left side and the bottom side. So this will still be h. Okay, so you will realize that sine theta 3 is now, so let's say if I carry on with my example of alpha to be 10 degrees, right? Theta 3 will be 190 degrees. So sine theta 3, which is sine 190 degrees, is actually negative y over h, which is negative. Cosine theta over 3, which is negative x over h, which is negative. Tangent theta over 3 is actually negative y over negative x, which is y over x, which is positive right now. So in the world of Q3, right, only tangent is positive. So this quadrant has a short form T. Only tangent is positive. Okay, so when I have all, I have sine, I have tangent. So it's clear that the fourth quadrant must be cosine. And just to complete the derivation, so I'll go to the purple pen. So you can see that I don't like to teach this picture with a static picture, teach this topic with a static picture in general, because once you look at the finalized art piece, right, the message is really gone already. Okay, so in the fourth quadrant, you have negative y, positive x, and h. Okay, this will still be the alpha, and the angle is this way. Okay, this will be theta 4. So sine theta 4 is actually negative y over h. Cosine theta 4 is actually negative x over h. Okay, and tangent theta 4 is actually negative y over x. So in the world of Q4, only cosine is positive. So giving us the namesake of C. Okay, so I had given you the alpha of example alpha of 10 degrees, but you will realize that actually it doesn't need to be 10. I just give you a numerical example to make you feel better. But in fact, the alpha or the theta one could be any angle between 0 to 90 degrees, and the whole theory still holds true, as long as I fit the angle within the quadrant in question. Okay, so collectively we have this ASTC or CAST, depending on where you start reading from, but always in anti-clockwise fashion, because that's the positive navigation in the world of trigonometry. Okay, so this one, right, is how we will use to solve trigo equations from now on. Okay, so what we have is this guy here. Oops. Okay, so this is the navigation plane that will help us to solve for certain questions. So what do I mean by this, right? Previously, in your Sec 2 trigonometry, it was always very plain and simple. Because there was always a context of a right angle triangle. With a context of a right angle triangle, right, it was always like, for example, if I have this theta, this is 1, this is 2. If I want you to solve for theta, right, you always say sine theta is equal to half. Then theta is equal to sine inverse half right away. Then you will have your answer, which was 30 degrees. Assuming this is degrees mode, it could be in radian mode for all I know. Okay, and then your answer will have just been this, because the context was such that you can only have a 30 degrees angle. If this is a right angle already, there is no way theta could be anything beyond 90 degrees, because that will violate the sum of angles in a triangle. Okay, so that was the narrative back then. But now, the whole concept of this chapter here in AMAP, right, is such that you no longer have a triangle context blocking you already. Having a triangle context, right, is a very EMAF thingy only. So you have your sine rule, cosine rule, area of triangle, and subsequently I'll teach you something called pairings, but not for today. So in the world of AMAF, right, it's a point blank solving an equation only. So sine theta is equal to half. I will tell you theta ranges from 0 to 360 degrees. Okay, then you will have to realize, oh, so you have to write like this. Theta, so based on my navigation plane above, right, theta could actually be in Q1 or in Q2 actually. So theta is in Q1 or Q2. Then the working here, right, up sine half is actually just alpha, not theta, the basic angle only. It's just that because the previous case on the right hand side, the triangle, right, if it's something below 90 degrees, it must be alpha. By definition, alpha is between 0 to 90 degrees. That's the reason why. So this will give you 30 degrees. So alpha is 30 degrees. I have two potential candidates, two potential answers for theta, and they could be in Q1 or Q2. So you'll just write theta is thus equals to 30 degrees or 180 minus 30 degrees, which is 150 degrees. So two potential answers for theta. theta cannot be in Q3 and Q4 simply because sine will be negative in those quadrants. So this is the Q1 equivalent. This is the Q2 equivalent, okay, for sine at least. So Howard, you should not have any issues with this right now. The Sec 3 boys, can you understand all this so far?
Yeah.
Yep.
Okay.
Yes.
Okay. Okay, so this is when I give you a positive ratios, okay, and it's easier that way. But if I give you a negative answer, right, say cosine theta is equal to minus half, okay. So the key element here is you will still okay, I must give you the domain. So theta would thus is in Q2 or Q3 because it's negative, right? So it cannot be in Q1 nor Q4. So you will write this alpha is equal to cosine inverse half, okay? I cannot emphasize this enough. It's half and not minus half. If you press up cosine minus half, you will have a totally different answer. So how to explain how come arc cosine minus half is still an answer, right? It's something that you only understand in IB or H2 JC math actually. So this one will actually give you 60 degrees. Then theta is thus 180 minus 60 degrees or 180 plus 60 degrees. So 120 or 240. So you must always press the positive value only in the evaluation of alpha. Okay, if you press minus half, right, then from 120 or whatsoever, you cannot get the answer already. Okay, so remember, we are always using the alpha to generate the answers for the relevant quadrants. So in order to do that, right, we must obtain alpha to be between 0 to 90 degrees. And to obtain a value that is between 0 to 90 degrees under the arc sine, arc cosine, or arc tangent formula, you must use only the positive values. Okay, so I have been giving you in terms of radians only. So I've been giving you the questions in these two examples in degrees only, but you need to be versatile in radians also. Okay, when the time comes. So remember, radians is about switching of the mode under the calculator over here. Okay, you should see a R here if it's radian mode and a D if it's degree mode. Okay, not to mention you still have to memorize our special angles. Because next lesson, you have more special values to memorize. So you have to memorize our 30, 45, and 60 degrees now ASAP. Okay, so we will spend the first half of the assignment going through more basic equations first as a form of revision. Then after that, I will teach you the more advanced stuff. Okay. Okay, so I'll go through these two questions with you first. Now, and in the kind of presentation I want to show you that the grader will be watching out for. Okay, if you look at these two questions, right, you will first realize that the measurement is in degrees, not radians, okay? And they want it to be 1 dB, all right? So the first one is easy. So you will just say sine x is equal to 4/10, which is equal to 2/5. Okay, you cannot be making careless mistakes when it comes to this kind of algebraic manipulations right now. So you will then write x is in Q1, Q2. There are only a maximum of 4 quadrants in this case because the navigation plane is 0 to 360. One full revolution is 4 quadrants, all right? Then from here, you'll write alpha is equal to arc sine 2/5. Okay? Okay, so for the sake of going through this, and the final answer needs to be 1 dB, right? So in the interim working, you need to write 3 dB. It's always the level of accuracy demanded on the final answer, right? Plus 2, okay? So this one should be 23.578 degrees, okay? Should the final answer is asking for 3 SF, your interim working, at least for alpha, right, should have 5 SF because plus 2 in terms of level of accuracy, okay? But if you don't wish to write this, feel free to don't write this and keep it in alpha will do also, okay? So then finally, I'll just write x is equal to alpha or 180 degrees minus alpha, giving you 23.578 or 156.422, then rounding off to 23.6 degrees or 156.4 degrees.
Can you just keep it like 23.6 and 156.4 and then write 1 dp?
Okay, so that means you are saying I will not write this line, is it?
Yeah, and then just write 1 dp.
Okay, so I strongly encourage you to always write out the preliminary answer before you round off, because you want to show the grader that you have rounded off accurately, just in case you round off incorrectly.
Oh, all right.
Okay, so David's question is, could he actually don't write this line at all? Straight away go for the numbers here, right? And then say, oh, 1 dp, 1 dp instead. So my encouragement is don't do that, just in case you round off incorrectly. Okay, so if I actually made a stupid careless mistake of rounding off incorrectly, right, by having the numbers here, the grader might be willing to keep one eyes closed for me if I had my presentation out perfectly all along. Okay, so that's one. And who knows, right, in a multiple parts question, right, you may need to use X to solve other stuff subsequently, right? And if you need to use X in other parts of the question, you should not be using 23.6 and 156.4. You need to be using these two answers actually. The +2 level in terms of level of accuracy. Get it? So 23.6 and 156.4 are the final answers to this part of the question, but they are not the numbers that you should be using to actually solve subsequent parts of the question, if that's our question. Get it?
Yeah.
Because if you do that, there's like a compounded rounding off, right? Then you are losing level of accuracy in every subsequent step, actually. Okay, so this is what I have here is the flawless presentation, at least for this question already. So what I want you all to always have, right, is this. You must always tell the grader which quadrants you interpret the answer to be in first, okay? If you don't want to, you don't have to write X is in Q1, Q2. You can just write Q1, Q2, okay? At the least give some inclination, okay? That's one. Second thing is, this one, remember, like I said, it must always be the positive value. Please write alpha here, not X. You're not solving for X explicitly because X could have a second answer. If you write X, right, then it's like, how come you can generate a second answer randomly? Okay, so please write these two things down. And then it's always a good habit to write out this thing here. Don't just write out 156.422 because we as a grader, right, we always hate it when a number pops out from nowhere with no workings to justify the thing. Working is a method, okay? So if you just write 156.422, right, imagine if I do not write these two lines, right, these two things, then it will be really, really awkward because where did the 156. I can understand where the 23.578 came from, but I will not understand where the 156.422 came from as a grader perspective. Okay, so you must always write this kind of steps down. So this also helps to understand, to tell the grader that I'm connecting Q2 to 180 minus alpha, and that is a correct movement. Just in case you use the wrong formula for the correct quadrant, then that will be the answer error, but the method will still be correct at the very least. So you can see that a short question like this has got a lot of presentation issues, and that is always the biggest thing in A math, because your questions are much longer right now, like parts A to H, especially for questions like coordinate geometry, right? So don't have premature rounding off error. That's one. Then you must show the grader how you're actually answering the question, how you interpret the question, and how you answer the question. That's the key thing to presentation for A math. Okay. E math, we are not so concerned with that. E math is just about answers, and more answers. Okay. So it's the same gameplay for part C on the right. So at this phase, right, the rule of thumb is you always want to have only one trig ratio present in the equation so that you can execute your ASTC, all right? You're not supposed to have too many trig ratios bumping around. So this will just be minus half 1 is equal to 2 cosine x. So cosine x is equal to minus half. So when I see this immediately, x is in Q2, Q3. So alpha is equal to cosine inverse half, which is 60 degrees. Yes. Then x is equal to 60 degrees, or sorry, Q2. So it's 180 minus alpha, 180 plus alpha. So it's 120, 240. Okay? Anyone, any questions on these two questions? So I cannot highlight this enough, in contrast to this guy. Okay. Okay. Any questions? Anyone? No? Okay. So we aim to spend half an hour or plus on this worksheet before we move on to the advanced one. Okay. Okay. So Pavan, why don't you try part B?
So first you have to divide the two.
Okay. So well, FYI, just to clarify, so tangent square x like this, right, actually means tangent x squared, okay?
Okay.
So in trigonometry, we don't write algebra like this. Somehow we put the power with the trig ratio, okay? Again, some wise old man in the past just say, let's do this, and everyone followed, all right? Okay, so what should you do from here?
So then x is in
No, we must do square root first, right? Because you should always have a power one situation.
okay. So then it would be tan x equals square root of 1/3.
Okay, actually it should be plus minus, all right?
Oh yeah, plus minus
So
square root
tangent
1/3.
x is actually plus or minus square root of 1/3, right? You get what I'm saying?
Yeah.
So this may seem confusing, right? Because tangent is both positive and negative, right? But it's just two cases, all right? And in fact,
Okay.
it's actually the best case. What do I mean by this, right? So actually tangent x is equal to square root of 1/3 or minus square root of 1/3, right?
Yeah.
Okay, if you look at the first case, which quadrants would it be in?
It's in the first quadrant
And
or first or fourth quadrant.
no, not
Oh sorry, first or third quadrant.
first or third quadrant. So
Yeah.
Q1, Q3, right? But what about the second
Yeah.
case?
It would only be in the it could be in the second or fourth quadrant.
Yeah. So if you look at this, right, which means that all quadrants are being considered right now, right?
Yeah.
Because collectively, because there are two cases and both cases are to be accepted, not to be rejected, which means that all four cases are being accepted under consideration. You don't have to go and think about AITC anymore. So it's just about all four quadrants then, which is the best situation actually. So
Okay.
alpha will be equal to
Um alpha is equals to tan x squared 1/3.
up 10, you mean?
Oh yeah.
Okay, up 10. So this will be equals to, and this will be equals to
Um square root 30.
30 degrees. Okay, so it's a special angle situation. You should have been triggered to memorize this also. Okay.
Oh okay.
So okay, then from here, x could be in. So x, what are the possible values of x?
X could be 30 or 240.
240 or not 240?
Wait.
Try again.
210.
210, well done. Okay. And
Then you have to use quadrant 2, right?
mm,
So when you put it in, so then it would be tan minus 1 bracket minus 1/3 square root.
wait, are you finding the basic angle now or what?
Because you still have to find quadrant 2 and 4, right?
Yeah, but they all have the same basic angle of 30 degrees, right?
Oh yeah. So Then quadrant 2 would be 150,
150. Okay,
and quadrant 3 would be 330.
330. Understand now?
Yeah.
Because these two answers have actually the same positive value, right? Have the same like net raw number. So they actually have the same basic angle. So using one basic angle here, we can actually generate all four quadrants answer actually. Get it?
Yeah.
That's based on the fact that it's plus minus. That's the reason why. All right.
Okay.
Okay. So if we move on to part D, right? Part D will be something funny. Okay. So you have to watch out for your calculators in this case. Now x is actually in degrees. Okay, but here this is actually radians. On the right side, it's just a pure number regardless. So it's actually and it's in radians because it's in terms of pi. Okay, so to evaluate the right hand side effectively, right, you need to go and convert your calculator to be radian mode first. Okay, and evaluate accordingly. So 0.5 cosine 3 pi over 4. So what I have here is based on my calculator, sine x is actually minus square root 2 over 4. Okay, so please make sure that you did this properly. Okay, under radian mode, and you get the same answer as me first. Okay, once you evaluate half cosine 3 pi over 4 in radian mode, right, you will then convert back into degrees. Okay, then to solve for x effectively. So the whole purpose of converting the guy to be radian, right, is just for the sake of evaluating this only, the negative square root 2 over 4, which I will teach you how to evaluate without a calculator later on also. So from here, right, you are supposed to say, okay, David, which quadrants could x be in now? So sine is negative, right?
Yeah. So
Uh-huh.
it can be in quadrant 3 and quadrant 4.
Yeah, okay. So we will still have the same thing. Alpha is equal to arc sine root 2 divided by 4, which will give me 20.704 degrees. 705 to be specific. Okay. So x is equals to 180 plus alpha, 360 minus alpha. Okay. Anyone, any questions on this?
Wait, how did you get to the minus square root 2 over 4?
Did you try pressing on the calculator?
Yeah, but when my answer is like a long string of decimal.
Okay. That's fine actually. You can have it as a long string of numbers. Okay.
Oh, okay.
And if you press it, and just make sure that you have the same answer here as me at the end of the day.
Okay.
Okay, so everyone please go and verify it. Your calculator may be of a slightly different version from me, so it may not display the cert. That's all. Okay, but regardless, right, it's actually possible to train to memorize all these things also. So let's try. So David, if you look at 3 pi over 4, right, what do you think it is in terms of degrees?
Pi over 4 is one of the values.
Okay, no, I just want you to convert to degrees regardless for the time being. So there are two ways of recognizing it as a special angle. So remember pi, what is pi in terms of degrees?
Is it, wait, I wrote it down, but is it 30 degrees?
No, pi. Remember degrees to radians, like 360 degrees corresponds to?
Wait, I have to look at it because I wrote it down. 360 corresponds to 2 pi.
So pi corresponds to?
Pi corresponds to 180.
So this is just 3/4 times 180 degrees actually, which is 135 degrees.
Okay.
Okay, so 135 degrees What's the basic angle of 135 degrees?
Wait, you're talking to me, right?
Yeah.
It's 135 degrees. Then it would be up sine. Is it up sine?
What's the basic angle of 135 degrees? What's the DNA of 135? Think back, picture 135 is here, right? Then what's this gap?
Oh, it's 45 degrees.
45, I understand. And 45 is a special angle, which means that 135 is a special angle, but in the Q2 version, that's all. Okay? Which means that cosine 3 pi over 4 radian, right, is actually the same as cosine 135 degrees. Okay? And cosine is actually negative in Q2, which means that this is negative cosine 45 degrees. And cosine 45 is 1 over square root 2, so this is negative 1 over square root 2. Then. So this is the train of thoughts if you really wish to convert it into degrees. Okay? So make sure that you're okay with what I'm writing over here first. Of course, if you can, I'm not saying that you can use a calculator regardless, but you need to be fluid in this also, okay, for some future questions. This is if I choose to convert the radians into degrees so that I'm easing you all into this, okay? Otherwise, right, 3 pi over 4, you must also recognize that it's a variant of the special angle pi over 4. So this is actually negative cosine pi over 4. Pi over 4 is 45 degrees, so it's negative 1 over square root 2. Then. If you can do this, that'll be great also. Okay.
Mr. Lu, can you explain again? I don't really understand the part that you highlighted.
The green one or the purple one?
A purple one.
Okay, so essentially, right, what I'm trying to say here is if you need to evaluate cosine 3 pi over 4 without using calculator at all. Oh, okay. I understand the idea first.
Oh, okay.
I want to evaluate 3 pi over 4 without using the calculator at all, right? So 3 pi over 4 starts off with has a radian, right? Okay. Yeah. I want to convert it into degrees first for you all to understand better. So under degrees is actually 135 degrees. Understand?
Oh, okay.
Then 135 degrees, you must then realize that it's actually the variant of 45 degrees, right? It's the Q2 counterpart of 45 degrees. Which means that since 45 degrees is a special angle, 135 degrees is also a special angle then.
Okay.
But in the Q2 version, right?
Yeah.
And is cosine positive or negative in Q2?
Cosine is negative.
Negative, which means that cosine 135 is actually negative cosine 45, get it?
Oh, yeah.
And cosine 45 is actually 1 over square root 2. So the thing you must memorize, which means that cosine 135 is negative 1 over square root 2 then.
But how do we get the negative cosine 45 is equals to negative 1 over square root 2?
Because cosine 45 is 1 over square root 2 by the special angle that you need to memorize.
Oh, okay.
The table of values, okay? From last week, can?
Okay.
So if you are quick in future, right, you don't even need to go through this step really. From 135, you are supposed to recognize that 135 is the Q2 variant of 45 degrees. And cosine is negative in Q2, then go straight to negative 1 over square root 2 in future. Okay? So the working in purple, right, is I still bother to convert it into degrees for you all, because I know that radian is not natural to anybody. Okay? But in future, you are supposed to be able to come to this level also, okay? You are supposed to recognize that 3 pi over 4 is the variant of pi over 4. And pi over 4 is a special angle. So 3 pi over 4 is in Q2, so you have this right away, the one in green. You can see that the thinking process for the one in green is a lot more efficient than the one in purple, of course. Okay? But I want to highlight, this is still not the purpose of this exercise here. This exercise, at least for this worksheet, is all about ASTC still first. Understand? Anyone, any questions? Howard? Pavan?
For the how is 3 pi over 4 equal to minus cosine pi over 4?
Okay, it's just like, do you agree that cosine 135 is negative cosine 45?
Yeah.
Then isn't it the same thing? This is actually the 135 but in radian, right? This is the 45 in radian.
Oh, okay.
Understand? Get
Yeah.
it? So that's why you need to be fluid in both degrees and radian, right? That's why I say all the like 30, 45, and 60 degrees, you need to see them as pi over 6, pi over 4, and pi over 3 eventually, actually. Get what I'm saying?
Yeah.
So that's where the real pain comes in. So there's actually two main things to learn. The how to solve ASTC's angles first, and memorizing all the special angles that pops up. Okay. This is the bit that will require the most memorization at Sec 3 level. Okay, so you have to do it regardless. Okay. Howard, okay, all this right? Howard? Howard? Are you there?
Yeah.
Okay, all this right?
Yes.
Okay, so let's move on to 2A now. Okay, 2A, Howard, you will try this question?
I think I changed the cosecant x to 1 over sine x.
Okay, so the fundamental rule, a basic rule of solving trig equations, right, is you do not want to have too many trig ratios working around. You need to standardize all the trig ratios. So we will never deal with secant, cosecant, cotangent. So we will deal with sine, cosine, tangent. Okay, so this one will give you 2 sine x is equal to 1 over sine x. And after that,
Is it I multiply the sine x on the other side?
yes, so you will have 2 sine square x is equal to 1. And
Then sine square x equals to 1 over 2.
okay, and then
Sine x equals to plus minus square root 2. I mean half.
so this is, like I said, the perfect situation. So which quadrants could x be in?
1, 2, 3, and 4.
Okay, so okay, because it's positive could be in Q1, Q2, negative could be Q3, Q4, so all sides are covered. Okay, which special angle is this? When is sine 1 over square root 2?
Is it 60?
No,
Then it's 30, I think.
no.
Yeah. Eh? Or it's sine 45. 45 degrees.
So alpha is 45 degrees, all right? So x is thus
55, 135, 225, and 325.
okay. So like I said, you need to always state working to how you generate those numbers I just mentioned, the 315, 225, 135, okay? So you should write this step down for yourself, okay? Get it? Can? So when you have plus minus, it's always a good thing because all four quadrants are covered. Don't have to think further, all right? So that's the best part. Okay? Okay. Yanis, you will try part D. Yanis, you there?
Yes.
You try part D.
Oh, okay. Do I do it out first or?
No, you can just say accordingly. I will do it.
Oh, okay. So it's 6 sine x equals to 1 plus 2 over sine x.
Okay, and then
Do I take away the fraction so I multiply?
Multiply both sides by sine x, actually. Okay.
Uh-huh.
So this will give you 6 sine square x is equal to sine x plus 2. Then you are supposed to recognize this is like a quadratic equation. It's like 6x squared equals to x plus 2. So we will shift one side to be 0.
Oh, okay.
Okay. So if you wish to, you can go and write something like this, but I don't encourage you to do that. It's just a waste of time. So it's like we see this as 6y squared minus y minus 2 is equal to 0. That's all. Okay.
Oh, okay.
Then you will try to factorize this now.
Factorize a 6y square.
So this one. So you have 6y squared minus 2 minus 1.
Oh,
So 3y, 2y, minus 2 plus 1. Get it?
yeah.
So you will have, okay, so I will not write it as y anymore. So it's like 3 sine x minus 2, 2 sine x plus 1 is equal to 0. Understand?
So are we supposed to like show this working out or?
Preferably, okay. If you don't want to, you can just use the mode 3 and solve for it regardless, right?
But we don't write y, right? We write sine.
Okay. No, some people just cannot visualize how it is a quadratic equation, okay? Then I'll teach them to see like this, that's all.
Oh, okay.
But if you can visualize it, so don't need to see the one in red. Just go to this right away.
Okay.
Okay, some people just cannot visualize it, so I have to teach them this. All right.
Oh, okay.
Okay.
But why is it like only the sine is square, not the x?
Okay, so sine square x, right? So sine square x is actually sine x times sine x. Right? This is an element on its own, right?
Uh-huh.
Whereas, so if you look at your working here, we are multiplying the sine x is one thing. It's not sine times x, man. It's like this. So
Okay.
if you multiply out, it's obviously sine x times sine x only, right?
Mm-hmm.
So that's why the x is never squared.
Oh, okay, okay.
It's actually one thing on its own. It's not sine times x. Okay.
Okay, okay.
It's like okay. Okay, so this kind is not a plus minus kind, then so it's a bit more troublesome. So sine x 2/3 or minus half. So two different cases, two different unique cases now. So for the first case, which quadrant is it? Could it be?
Quadrant 1 and 2.
Okay. And the second case?
Second case is 3 and 4.
So you have to write something like this down already. So I will get a bit lazy now. I'll just write these things. Q1, Q2, Q3, Q4. Then what should be the working to solve for x in both cases?
So x equals to
Not x. We have to do something first.
oh, is it the quadrant?
The basic angle first.
Oh,
So
uh,
alpha is
oh,
equal
alpha is equals to sine -1 bracket.
You can
Huh?
say sine inverse or arc sine.
Okay, sine inverse 2/3.
Which will give you, press on a calculator, so 41.810 degrees, okay? So guys, you must get used to your calculators on these things, right? So because, how do I know that it's a messy number, right? It's because 2/3, right? It's not the output of any nice numbers at all in the world of trigonometry, okay? So you have to be sensitive to these numbers also. So remember to have this special angles table on your side for yourself right now during this period of time, okay? Or when I'm going through this in class, okay? Then on the other hand here, alpha. Okay, so Yanis, for this one, right, do I press arc sine half or arc sine minus half?
Without.
Without. Okay, so arc sine half, you have to remember that half is actually a special angle situation. So you will actually get 30 degrees here, all right? So if you don't believe, you can try it out on your calculator also. You will get 30, all right? Okay, then the final answer for the first case, x is equals to?
Oh, x is equals to 41.8
Or
or Q2 or 138.2.
yes. Okay. So I will not write out the final answer. I just show you all the working only. And in the second side,
Second side is 210 and
0, okay.
330.
Okay. Understand now?
Yeah.
So this part of the quadratic is something that you need to get used to. Okay. So it's just exposure for you. All right. Okay.
Okay.
Okay. Pavan, you will do this one.
So it's a quadratic equation, right? So then you have to factorize it. And I can just use multiplicity, right?
Yes.
Okay, so then it would be 3 sine, yeah.
Cos are not sine. Yeah?
Oh yeah, sorry, 3.
Okay. Then from there, cos x is equals to
Cos x is equal to 1 over 3.
okay. Or
And then minus 1 over 3.
okay. So which quadrants are they in?
Cos x equals half is in the first quadrant or the last quadrant, and then the minus 1 over 3 is in the second quadrant or the third quadrant.
Okay. So what should I do next?
Then you have to find the alpha.
Okay.
But then
Uh-huh.
yeah, and then
This is actually a special angle. So up cosine half is actually
45, I
no.
think. Oh wait, no.
That will be 1 over square root 2.
Oh. Wait. Cosine. Okay. Would it be 60?
It's 30 degrees actually.
Oh, 30. Okay.
So the other side will be, what should I do on the other side? Alpha is equal to up cosine minus 1/3 or 1/3?
1/3.
1/3, okay. So this one won't be a nice number. So
Um.
70.529, okay.
Yeah.
Okay, then your final answer for the first case, what's the final answer?
30.
30 and
Wait. 30 and that's quadrant 4, so 330.
330, 360 minus 30, yeah.
Yeah.
The second case,
Quadrant, so 180 minus 70.529.
you can just say alpha will do, okay. So
Oh, okay.
180 minus alpha or
180 plus alpha.
180 plus alpha. Get it? So these are the 4 answers.
But then, for example, in exam, if I'm showing my if that's my answer, can I write alpha?
Yes, then of course you must have a final numerical answer. Because even though I did not indicate alpha over here, right? But at the very least, I have actually stated what alpha should be, right? It's just a case of lazy presentation, that's all. I did not put them in yet. Get it?
Oh, okay.
I'm working here already convey my train of thoughts and my ideas already.
Yeah.
So which means that all I need to do is to press calculator to evaluate, that's all. So as long as you have steps, even though they are in variable form, right, it's still working regardless. Okay.
Okay.
Okay, David, you will try part E on the right.
All right. So tangent x plus 2 over tangent x is 3. So can I change tangent x to like a? No, so b, because we already have alpha, right? So can we do a? b plus 2 over b is 3. So b squared plus 2 is 3b. Yeah, so b squared minus 3b plus 2. So that would be b minus 1 and b minus 1, b minus 2, yeah. And then so tangent x is 1 or tangent x is 2.
So which quadrant are we looking at?
So we're looking at all the quadrants, but actually no, not all the quadrants, because x is so if it's 1, then it's 1 and 2, then both are positive, right? So then it's Q1 and Q3.
Good. For both cases,
Yeah,
right?
for both cases.
But they have different alphas. So alpha is arctan 1. Arctan 1 is equals to?
Arctan, wait. That's equal to 1 over 4 pi. Oh wait, I'm in radian mode. Sorry.
Yeah. So it's 45 degrees. Okay.
Yeah.
So on the other side, I'll give you 63.435. Get it now? Okay.
Mm-hmm.
So then x is alpha or 180 plus alpha. Okay. And x is alpha or 180 plus alpha. That's all. Get it now?
Yeah.
Okay, so all these things are in degrees mode, so you are getting used to this. So it's just a matter of presentation, that's all. Okay, so I will expedite this a little bit now. So, okay, so you will see some of these questions are no longer in degree mode. Okay, question number 3A is still in degree mode, but the scale are different right now, right? So if you look at this carefully, is this. Okay, so what does it mean, right? Negative angles, as I said before, it means start from the horizontal x-axis but navigate in the opposite direction. So what it means is if I have a navigation plane that's like this, Q1 and Q2, we will still move in this direction. Okay, Q3 and Q4, you are supposed to navigate in this direction. This is in contrast to 0 to x to 360 degrees. So you have two different flights. Get it? So when it comes to these guys, there are a few ways to handle this. You can now call this quadrant Q minus 1 and Q minus 2 because you are moving in the opposite direction. So instead of the conventional Q3 and Q4, is accepted notation. Okay?
But at the end of the day, isn't it basically the same thing?
It's still the same thing, but the answer must be presented differently, which means that if your answer is 190 degrees, right, we expect you to change your answer to be a negative answer, that's all.
Oh, okay.
Because 190 degrees exceeds the range here.
Okay.
Okay, so there are two ways to solve this kind of questions. I will show you both ways. So, okay, so 3B, right? You can still solve it like a normal quadratic equation first. You want to look at it, you already know that it must be a quadratic already. So I will have 6 is equal to 11 sine x minus 4 sine square x. So 4 sine square x minus 11 sine x plus 6 is equal to 0. So I will try to factorize this. So 4 plus 6 minus 11. Oh my. So 2, 2, 3, 2, 4, 6. No. Can anyone do the mode 3, 3 for me? Anyone? Hello?
X minus 2 or 4x minus 3.
So sine x minus 2.
Or 4 sine x minus 3.
Okay. Okay, so sine x is equal to 2 or like this. 4 sine x minus 3, is it?
Yeah.
Okay, so this one, we cannot escape from the situation. Okay, this one, right? If you press on the calculator, sine 2, you will get rejected, math error actually. So this one is NA already. So this one, I will only explain in next lesson onwards. Whenever sine and cosine exceeds 1 or -1, right, it will be math error actually. Okay, so don't worry about this for the time being. So this one, right, what do I mean by we escape the domain, right? It's because this guy is in Q1, Q2. Q1, Q2 means if you look at the domain, it's just 0 to 180 degrees. So we need not touch on the negative angles at all. So we are safe from there. So it's just arc sine 0.75. So I'll just write, I'll expedite the workings. So alpha is arc sine 3/4. So x is equal to alpha or 180 minus alpha, that's all. Okay. But what I'm trying to say in this question here is if my answer was like 100 and let's say 350 degrees, for example, 350 degrees would not be an accepted answer under the domain prescribed by the question, which means that I need to rewrite it into its negative form. So, Yanis, 350 degrees, what do you think is a negative version?
-10.
-10. So you have to rewrite this as -10 degrees then. Get it now? And -10 fits under the domain here, so that will be an accepted answer. Get it?
So we calculate like the last part x equals to something or something, then we change it to negative.
If your answer exceeds 180 degrees.
Oh, okay.
But in my current working now, the one in red, right? I'm in Q1 and Q2. Q1 and Q2 is in the safe zone. Get it?
Oh,
You're
okay.
in the danger zone only when you touch Q3, Q4.
Okay.
Okay. So I think 3B somehow they set it like this, but 3A should be fall under the thing that you need to change your answers a little bit. Okay, so I'll leave that as homework. Because I still have one more worksheet to cover. Okay. So 4 is the start of your radian mode right now. So when it comes to solving algebraic stuff, right, remember you are not supposed to divide algebra, you can only factorize, okay? So if you look at 4, it's clear that we are looking at radian mode already. Okay, because everything is in radians right now. So, okay, Howard, you try 4A?
Two sine x equals to 1.
Let's say you cannot divide by algebra. Imagine if I have 2xy is equal to y. Am I right to say 2x is equal to 1?
Oh,
Not supposed to do that, right? What are you supposed to do? Bring one side and factorize.
Oh,
Okay. You're supposed to do this 2xy minus y is equal to 0, then y 2x minus 1 is equal to 0. Okay.
so cosine x bracket 2x minus 1
okay.
equals 0. So cosine x equals 0 or sine x equals half.
Okay, understand now? Okay, so cosine x is equal to 0, right? I'll give you the answer. How to solve this kind of questions explicitly, right? The one in yellow, I will only address it at the next lesson, okay? So cosine x is 0 at, okay, how, when is cosine 0? You should know, but not the sec 3s, that's all.
Oh,
Radian mode,
pi.
No, not pi. Pi over 2 and 3 pi over 2, okay? 90 degrees or 270 degrees. Okay? Howard, are you there?
Yeah,
Understand? Or you don't even remember these things right now?
I forget all the special angles.
It's not special angles, or this is a graph. You also forget already.
Oh yeah,
Okay, and then the other one? Okay, the other one, which quadrant is this?
first and second.
Okay. And the special angle is?
$60
No.
or 30.
Okay, but this question is in radian, right? So it's not 60 or 30.
pi over 6.
Pi over 6, okay? So everyone, you must be careful of this. So in this case, if you press on the calculator, if you switch your calculator to degree mode, okay? If your calculator is on degree mode, you press up sine half, you can get 30 degrees. Then you must instantly recognize that it's a special angle. Then you must tie into the fact that this question is in radians. Then you will write it in pi over 6, okay? 30 degrees. If you configure your calculator to be in radian mode at the start, then you press up sine half, you're just going to get a string of numbers that you may not recognize as pi over 6. So that's why net, at the end of the day, you still must be sensitive to all your special angles and the outputs. Okay. So you must be aware of. So you will find your own exam tricks on these things. So the most common exam trick is to turn this in degree mode first, then solve it in degrees, then change everything to radian at the end of the day. Okay, because at least it's still recognizable that it's 30, 60, or 45 degrees. So from here, okay, Howard, what's the formula for generating answers for Q1 and Q2?
X equals to alpha, comma 180 minus alpha.
You have 180 here.
Pi minus alpha.
Pi minus alpha, because this question is in radian mode right now, okay? Okay, for the sec 3s, right, when sine, cosine, or tangent are equal to 0, 1 or minus 1, right, it's always a extra special situation, like in this case, okay? Like in this case, when sine, cosine, or tangent are 0, 1, or minus 1, they are the extreme special case, which I'll only address next week. So don't worry about this. So that's why I'm just giving you the answers right now. So here you have these 4 answers over here, okay? So this is just to show you that it may not be easy to solve things in radians unless you know your special angles very well. Of course, there are exam tricks to work this in degrees first, then convert back into radians. That is a very common exam maneuver, but it's very inefficient, that's all. Okay, and I don't encourage that in general. Okay. Anyone, any questions on 4A? Anyone? Feel free to sign off. Huh? No questions, I will move on. Okay. So 4B is something that you will try to do as your homework, all right? Okay. So 5A is the same gameplay, nothing fanciful. So I don't want to spend time on that. 6 is the one that is more intriguing. Hence, I want to do it with you. Okay. So 5A is about simplification, factorization, and then get the answers. At least it's in degrees, so it's manageable. So I don't want to spend time doing this with you. 6 is the one where there's a bit more work to be done. Okay. Firstly, there's 2 layers of difficulty. It's in radians. Not to mention, it's not 0 to 2 pi. It's minus pi to pi. That means answers in the Q3 and Q4 have to be rewritten in the appropriate fashion. Okay, that is always a problem. All right. Okay, so 6A, right? As I mentioned, you should never have too many trig ratios lurking around in a single equation. So when you see this, you must straight away turn it into a singleton trig situation. And for sine and cosine lurking on each side, right, the trick is always to turn it into tangent. So I'll divide by cosine on both sides. So 1 is equal to square root 3 . Okay, which means that tangent x is equal to 1 over square root 3. Which means that we are looking at Q1 and Q3 because tangent is positive. And alpha is equals to arctan 1 over square root 3, which will actually give you pi by 6. 30 degrees, FYI, okay? Now, okay, so with this, right, David, try to finish up the question for me.
So it's pi. So it's
sorry. Yeah. So think back to the compass whenever you are lost. So we are looking at this quadrant and this quadrant, right?
Yeah. So it's
Okay, so for the first quadrant, it's obviously easy, trivial, right? This way, right? Agree?
mhm. Yeah.
So x is equals to pi over 6 still first, okay? But the third quadrant's answer is the one that's giving you a problem right now, right?
Yeah.
Okay, so if you find it hard, right, solve it in terms of 0 to 2 pi first. If it's in the Q3, it's this way, right? The one in red, my ink in red.
So it's 180 plus.
Okay, not 180 because this is in radians. So it's pi plus.
Pi plus pi over 6.
And this will actually give you, so this is a Q1, Q3, right? This is actually 7 pi over 6. Okay? If you ignore the pi, just focus on the fractions. It's just 1 plus 1 over 6, which is 7 over 6. Okay?
Yeah.
Okay, so which means that this angle in red is 7 pi over 6. Get it?
Mm-hmm.
But 7 pi over 6 exceeds the range enveloped by the question.
So it's rejected.
No, you will have to rewrite this into a form that fits. So what is 7 pi over 6 in terms of its negative answer, right? That means this direction, this angle here, right, can be also be derived from this angle here. Get it? The red angle is the same as the green angle, actually, from an angular displacement perspective. Yeah, follow?
Yeah.
So what will be the size of the green angle then, in terms of radians?
Mm-hmm. That would be 360 is 2 pi. So 2 pi minus 7 pi over 6.
Okay? So it will be 5 pi over 6.
Pi over 6. Yeah.
Actually, negative 5 pi over 6, okay? Because you should be taking the red minus 2 pi.
Oh, yeah.
Because the green is navigating in the clockwise direction, so it's actually negative. So this is actually equals to minus 5 pi over 6 then. Understand now?
Yeah.
And that will be the answer, okay? So this and these are the answers. So you can see that this kind of exercise forces you to think in terms of the navigation, positive or negative angles, degrees and radians all in one, okay? Even though I've been teaching this like separately, right? But the questions will never test you individually like this, okay? Okay on this, everyone? Any questions first?
How come for like the first step, right? How come you divided everything by cosine? Because I thought just now you said that we cannot divide everything.
Okay. In this case, when you divide, right, it's not the same as Howard's way of doing. Howard's way just now was a cancellation. I'm not doing any cancellation here, you see.
Oh.
You get what I'm saying? If I
Yeah.
say x is equal to 3y, right? I can still have 1 is equal to 3y over x. I'm not doing any cancellation, right?
Yeah.
But if you have x square y is equal to y, then you are doing like this. This is equals to this is okay. Understand?
Oh, okay.
So the proper way to handle the thing on the right hand side is actually x square y minus y is equal to 0, and y x square minus y is equal to 0. Get it now?
But then why can't you just divide everything by y here and then 0 over y is just
You mean on the left or on the right?
no, on the right
The
side.
green,
The right side, the red one.
the red one. What did I do?
Why don't you just divide everything by y? Then it just becomes x squared minus 1 equals 0.
But then that will be exactly the same thing as what I did in the green already, right? It's like x. No, if you divide by y, is it? Like this?
Yeah.
Y right now, is it?
No, as in for the red one.
For the red one, what did I do?
Just if you divide by y, then it just becomes x squared minus 1 equals 0. So you get the same thing as the green one.
Then I'll get the green one, isn't it?
Yeah.
Okay, but the one as in what's wrong with this, is it?
Yeah.
Okay, because in this case, let's say y is equal to 0 or x squared minus 1 is equal to 0, right?
Oh.
The one in
Okay.
green would forego this solution already.
Yeah.
Which means that it's not okay then. Get it?
Yeah.
But if you look at my situation here, would it my 6a here, right? Is it possible for such a situation to arise? Like cosine x is 0?
No.
Because I have sin x on the other side. If I have a
Yeah.
cosine x on the other side, then I cannot do the division like this.
Oh, okay.
Get it?
Yeah.
I'm just shifting on one side. I'm not doing cancellation. It's not the same thing. Okay.
Okay.
So any undone questions here, you will finish it as your homework. So I want to actually spend the remaining time going through a more advanced situation where the domain is tweaked further. Okay. So something like this. So sorry that there's no break today. So we are back to degrees mode in this case. So the first linking that there's something different about this question, right, is the fact that the angle provided, the domain provided, right, is x. And they tell you it's 0 to 360. Okay? But the angle captured by the trigo in this question is 2x. So first things first, there is a mismatch. Okay? So remember, we are solving for x fundamentally, but the angle captured by trigo is not in 2x, right? Which means that we must tweak our domain to be in terms of 2x first. So we will always write this out properly. So x is between 0 to 360, but 2x is actually between 720 to 0 degrees. So 720 degrees, right, means it's 2 full revolutions around the ASTC. 2 full revolutions means it's 8 quadrants are involved. Q1, 2, 3 has the first revolution, 5, 6, 7, 8 has the second revolution. And you need to have both. Okay, consider 2 full revolutions now. So what do I mean by this, right? So sine 2x is equals to a quarter. So I'll write this 2x. Okay, we are solving for 2x because 2x is the one that's captured by the trigo. So 2x is in Q1, Q2, first revolution, Q5 and Q6, the second revolution. Get it? So it's always, you can see that the second, every one revolution, right, is 4 quadrants, right? So it's always a +4, +4, because it's like you move one round around the track. If I'm one round faster than you, right, that means I ran 400 meters ahead of more than you. In our trigonometry CAST, 400 meters refers to 4 quadrants, so it's +4 in terms of quadrants, in terms of the elevation of quadrants. Okay, understand so far, everyone? Any questions? So you need to write this down: Q1, Q2, Q5, Q6. That will give you the inking that, oh, there is a second revolution coming into play here. Then you will write alpha, same gameplay, up sine half, a quarter, sorry. Okay. Then I want you to always maintain this habit, 2x, okay? Because the angle is the angle captured by the trigo is still 2x. So all these steps are solving for 2x. So this will be equal to alpha 180 minus alpha, the one for Q2. 360 plus alpha. 360 plus 180 minus alpha. Okay? So once again, this guy's first revolution, his counterpart for the second revolution is this guy. This guy corresponds to this guy. Okay? +4 quadrants is the same as plus 360 degrees. Of course, if this question was in radians, it will be +2 pi then. Okay, on this, anyone, any questions? Then only when you are here, then you can finally solve for x. So x is equal to alpha over 2, 180 minus alpha over 2. Of course, you need to evaluate this numerically for your final answer. I'm just not doing it right now. Then, get it? And you need to check that all your final answers, 4 answers are all within the domain stated. And that will be the final answer then. So this is when these kind of questions are when there is a mismatch between the variable stated and the variable captured by the trigo. So in this case, the variable stated is in x, but the variable captured by the trigo is actually 2x. So there's a mismatch. So we will always adjust or realign this guy to match this guy. Okay, I cannot change the equation. I can change the domain stated so that I know where to scan for my horizon. Scan for my answers, I mean. Okay. Sometimes it could be expensive, like expanding the domain to be scanned. So like 1a, because it's 2x. But 1C is x over 2, right? That means you are restricting the domain to be scanned, that's all. Anyone, any questions on this? So if you master this, you master like 75% of solving of trigo equations already. Not to mention your degree, radian, special angle still. Okay, anyone, any questions? Yanis, any question?
So if it's like C, if it's x over 2, so is it like 360 must divide by 2 or something?
So we are only scanning for answers in the first 2 quadrants only.
Okay.
And because cosine is positive, right? So I know only Q1 is activated. So net only got one answer only.
So if x increases, the degree also increases.
That means your territory to be scanned is increased. Understand?
Okay, can.
Okay. So any more questions on this?
Wait, you'll send us the recording of this afterwards,
Yeah,
right?
of course.
Okay, thank you.
Okay, so Yanis, you try the next one. Okay, you try 1B, Yanis. So it's 3x over 2. X is between 0 to 360. So tell me you're working.
Try B, right?
Yeah. The 3x over 2 one.
Oh, okay.
So study the new domain first.
3x over 2
Is now between
is 0
0.
and negative 3 over 2.
No. As in the new domain to be scanned. Like this step, this thing here.
Oh.
So it'll be 3 over 2 times.
360.
So it's 540. Understand? Okay. So you must understand where is 540 until
is until
which quadrant?
it's until the second quadrant. No, sixth quadrant.
Second quadrant.
Huh?
Second revolution, second quadrant. You get what I'm
Yeah.
saying? So it's Q6.
Yeah.
Q1, 2, 3, 4, then 5 and 6. Understand?
Yeah.
So when I see this mentally, I'm really thinking, okay, I'm looking at Q1 all the way to Q6 already.
Mm-hmm.
Okay. Now tangent is negative. So which quadrant are we looking at?
Second and fourth.
Second, fourth,
And sixth.
yeah. So it's Q2, Q4, and Q6. Understand?
Mm-hmm.
We need to go to Q8 because outside the boundary already.
Okay.
So, and once again, first revolution, right? Second revolution plus 4 only. Get it? Okay, then what should I do from here?
Then after that you find the what's that called?
Basic angle.
Yeah, basic angle. So tangent. What's that called?
Arctangent
Sorry, arctangent.
or inverse tangent, okay?
Okay. Then or do I calculate that?
Yes.
Okay.
Actually, don't need, leave it here will do. Then how to generate the answers for Q2, 4, and 6 now?
So 3x over 2 is equals to what's that called?
180 minus, this is in degrees,
Equals to 180 degrees minus what's it called, I forget the name for the alpha, and then after that is number 4 is 360 degrees minus alpha.
Okay, this is the Q2 and Q4.
Yeah. And then after that is 360 plus bracket 180 minus alpha.
That's the Q6. Understand now?
Yeah.
Okay, so everybody, you all must understand this. To elevate to the next revolution, right? It's just plus 360 only. Okay, just think of it as running around a track. That's all. So finally, remember our job is to solve for x, not solve for 3x over 2. So x is thus 2/3 than everything else. Okay. Get it now? Okay, guys. Are we all okay on this? Guys, Yanis, okay with this?
Yeah, should be.
So you must be sensitive as to 540 degrees, which quadrant is this, and so on and so forth. So if you go back to the AITC navigation plane, right? So this is actually 0, 90, 180, 270 for the first revolution. But if you carry on, right, this will be 360, this will be 450, second revolution, 540, then 630, 720. Okay, then moving on, then you will have like 810 and so on and so forth. Okay, so it's always plus 90 degrees. So you must know which revolution and which quadrant. But I purposely put Q6 sometimes is to teach myself that, is to remind myself that it's a second revolution. Okay, most of your teachers may have a different way of presentation in the school itself, but I feel that this is the safest and the most robust way of thinking and presentation already. Okay, so remember, this is when there's a mismatch between the domain stated by the variable and the angle captured by the trig equation. We cannot change the equation, but we can change the domain. That means I tell you to scan for a wider or narrower horizon. Okay, so this one is when it's a scaling, multiplication of the angle of the x. Okay, there is a different kind where it's just a plus or minus. So these things that you see in 2a now. Looks difficult, but easier than it seems. But as you can see, we are giving you in degrees to ease you into the radian thing already. Okay, so you can see when there's a slight shift in the domain, right? So how do we adjust this? So 2a, I have tangent being positive. I have the normal scanning horizon is 0 to 360. So the full first revolution, Q1 to Q4, right? But now I have plus 40. So I will do this. So x is between 360 to 0. So x plus 40. Always study the angle, the spanning space by the angle captured by the trigo equation. So this is thus between 400 degrees to 40 degrees now. Okay? Now, 40 degrees to 400 degrees gives you a lot of headache, right? If you think too hard. Because it's like half or part of Q1, then Q2, Q3, Q4 are fully encompassed, and then Q5 is half of Q5 again, or part of Q5. You get what I'm saying? It's not the entire Q1, neither is it the entire Q5, but parts of it only. Okay? So it's like if I have a navigation plane, it's like I start from here, this is the 40-degree mark, then I move one full round, and then come back here again. So it's a little bit troublesome if you think too much about it. Okay? But as a rule of thumb, right, I will teach you the easy way out of this. The easy way out of this is, as long as the quadrant is slightly infringed upon, even if it's not fully enveloped, right? As long as it's infringed upon, you take the Kiasu approach and account for it first. So in my case, I already know that this ranges from Q1 all the way to Q5. Okay, even though strictly speaking is parts of it only, but I will still account for the whole quadrant first. So once I account for the whole quadrant, x plus 40 degrees is in Q1, Q3, and Q5 because it's positive. Then alpha is equal to arctangent 2.112. So in this case, I will evaluate out for you. 64.66. So I'll just be lazy a little bit, just write 2 dB. So it's 64.66 degrees, which means that x plus 40 degrees is 64.66 244 64.66 or 64.66, 424.66, okay? Which means that this was alpha plus 180, Q3. This was alpha plus 360. My stylus is failing soon. Okay, so this is alpha. Q1, Q3, Q5, okay? Then finally, x is equals to 24.66, 204.66, 384.0, 384.66. Get it now? Okay. So I have fully accounted for all three quadrants, right? Even though they were slightly touched upon only, or envelope partially only. But now I have three legitimate answers for x, right? And you have to check back to the original domain now. The original domain says is 0 to 360 only, which means that my third answer here has to be rejected then. So the answers are just these two answers there. Can follow? Which means that what I'm doing here is I'm adopting the Kiasu approach. I'm over accounting for it first, and I'm fine with that as long as I reject at the end of the day. I don't want you to like try too hard to slice and dice the domain of the question first, right? And then trying so hard to solve for part of Q1 or part of Q5. Much easier to just account for it, but only slash it down at the final step by watching out for the domain. Understand the logic behind this, guys? So you can see a shifting in domain left or right? It's actually harder than a multiplication when you're expanding it or shrinking it by a multiple. Okay on this, everyone? Hello?
Yeah, I'm okay.
Okay, Howard, David, Yanis, any issue on this?
No.
Okay. So once again, these are all in degrees, right? If you have it in radians or negative angles, there will be a another kind of nightmare again. All right. Okay, so Pavan, you will try 2B. So x is actually originally between 0 to 360. Yeah. So now I'm minus 75.
So first you have to so 0 is greater than or equal to x minus 75. Okay,
I can't hear you very well.
Oh yeah. Can you just hear me better now?
Not great.
Oh. Um. Wait. Let me try. Give me 1 second now.
Are we there?
Wait. Can you hear me better now?
Yeah.
Okay. So then it's 0 is greater than or equal to x minus 75, which is greater than or equal to 360 minus 75, which is just 285. Then wait.
Okay. So this is the equation, all right?
Yeah.
So which
Then
quadrants are we looking at? Which quadrants are we encompassing?
quadrant but since it's negative.
So it's quadrant -1.
Oh, okay, yes. Quadrant -1.
All the way to
285 is quadrant. It's also including quadrant 4.
yeah. Okay. Understand now?
Yeah.
So actually it's like I have the running track here. I start from here. So this is -75 degrees. Then at the same time I also have this way. Understand?
Yeah.
Okay, so So there are a total of 5 quadrants under consideration, and that's the game to play for this one. All right.
Okay.
Okay. So sine is negative. So which quadrant are we looking at now?
So wait, sine is negative, which means you're looking at quadrant quadrant one quadrant one.
Quadrant 1 is
Oh
not.
wait, no, sorry. Quadrant -1,
Okay.
quadrant 3, and quadrant 4.
Okay, and that's it. So if you
Yeah.
want to visualize the quadrant -1, keep it at the back burner first. Okay.
Okay.
But now let's look at, so now alpha is still, the basics don't get adjusted. So it's still up sine 0.184. Okay. So up sine 0.184. If you not negative 184, so it's 10.6 degrees.
Wait, but how do you know that x is negative?
I didn't know that my x is negative.
Oh, because then why do we say that x is why do we say that it was negative?
As in x minus 75, is it?
Yeah.
Okay, and then how do I know that it's q -1, is it?
No, as in like because how do you know sine is negative?
Okay, do you agree that q -1 is the same as q4?
Yeah.
So is sine positive or negative in that quadrant?
Negative.
So I should account for it, right?
Yeah, but how? No, I'm saying how do you know sine is negative in the first place?
Because the question says so. Sine is negative, right?
Oh. Yeah, sorry.
Yeah. Okay. Okay.
Yeah.
Right. I mean, the
Yeah.
basics from the previous worksheet don't disappear in this worksheet. All right. They add on. Okay. You get it now? Okay. So from this alpha, you sound like
Yeah.
you're in a train station.
Yeah.
Are you in the train station?
No. Because one of my headphones doesn't work,
Oh,
and
okay.
the other headphone died, so I'm using the one that's a bit weird now. So it sounds weird, yeah.
Okay. So with this alpha and these 3 quadrants, what will be the values for x minus 75?
So wait. So just plug in sine -1 0.184 into the calculator, right?
I don't understand your question.
So just put into the calculator, right?
Why do you need a calculator for this?
Wait, what?
Okay, okay, with the value of alpha and with the
Yeah.
appropriate quadrants, what's the working or what's the formula to calculate the relevant answers? Do you get what I'm trying to say?
Oh, so the first one would be alpha
For which quadrant?
for quadrant -1, or it will be 360 minus alpha.
Okay, give me the one for Q3 and Q4 first then.
180 180 minus alpha for Q3. I mean 180 plus alpha.
And
Then Q4 is 360 minus alpha.
okay. Okay, so guys, how to get the negative quadrants, right, is to understand this. So ASTC, right, is always alpha is this size. Okay, I understand it. So Q4 is the same as Q -1, right? But we write the answer in the negative format. So let's just say if I have something in Q4, right? Q4 will be like this. Okay, let's just call this theta 4 then. And if that is theta 4, this little green gap here is actually alpha in this guy, right? Pavan, do you agree with this?
Yeah.
But now if I want it to be Q -1, that means you are just navigating in the opposite direction all along, right?
Yeah.
And that will be this way, which means that the net displacement is just negative alpha.
Oh.
It's just like in the world of trigonometry, 340 degrees, the same as negative 20. Get it?
Yeah.
So 315 degrees is the same as negative 45 degrees. Okay?
Okay.
So this is just negative alpha actually. Understand now?
Okay.
Okay, so I understand this is not easy to learn this for the first time. So there's no need to over memorize the formula. Always remember the navigation plane in your head. That will make it a lot easier. Okay.
Okay.
Okay, it's okay. You can turn off the headphone. Okay. Then from here, right, you are supposed to evaluate the values of x then. So x is equal to minus alpha plus 75, 180 plus alpha plus 75, 360 minus alpha plus 75 then, okay? Then you have to check that all three values, whether all three values lie in between 0 to 360, okay? All right, so this is it for this kind of situation where you have a shift and you have a negative quadrant, okay? So these questions are all in degrees, so they are still user friendly. There, like I said, there could be in radians waiting for you, right? Like here, okay? More than that, there could be a shift of two things at the same time. So for example, let's look at 4a, 174. Okay. So I'll just do, let's just do 5c then. Okay. Okay, David, you will try this question, okay? So let's just say if you're looking at 5c, how will you approach this question?
Well, I would think that it would be 50. X, the boundaries would be 50. Wait,
Okay, I'll write it out properly first, so don't worry, just tell me, so x is between 0 to 60, right?
yeah.
So 2x plus 50 must be between
50 and 770.
770. So which quadrant would this be? So which quadrant is this ranging from?
This would be from quadrant 1
All the way to
quadrant 6.
no, more than that.
So 360 and then 720. So quadrant 9, sorry.
Quadrant 9, okay, which is the first revolution, the first quadrant of the third revolution, okay?
Okay.
Yeah, so you are not finishing, you are just a little bit of the third revolution, that's all. Get it?
Yeah.
Okay, but since now sign is positive, so which quadrant are we looking at?
We're looking at it's positive, so we're looking at quadrant 1, quadrant 2, and quadrant 5, quadrant 6,
and quadrant
8, quadrant 8. Wait, no, quadrant 9. Sorry. Yeah.
Quadrant 8 is actually the Q4, the second revolution, right?
Yeah.
Okay. So you can see that there's a linkage here, plus 4, plus 4, okay? And the linkage here would be plus 4. Get it? There is no need to go to the Q10 because it exceeds the boundary here already.
All right.
Okay. So there is no Q10 simply because of this limitation, that's all. All right. Then from here, you should always calculate your alpha now. Alpha would be arc sine 0.509, which will give you, this is in degrees mode, so arc sine, so 30.6 degrees then. So I'm just writing 1 dp for easier writing, okay? So we have 5 answers under consideration. We will then write them all out then. So remember, the angle that we are solving right now is still not x explicitly, but 2x plus 50 degrees here. So 2x plus 50 degrees is then equals to alpha, 180 plus alpha, 360 plus alpha, 360 plus 180 plus alpha, and
wait, I have a question. So actually, if you know the you don't really need to memorize this, right? Like Like you don't need to write down like 180 plus alpha. Like you can draw it out and then you can actually just write down 180 plus.
Say that again. That means give the numerical value right away, is it?
Yeah, and then draw it out. Like draw it out first because like I don't don't think I can really memorize.
All the formula, is it?
Yeah.
Okay, so it should have been a mistake. Should not be, it's minus. So you will get used to it eventually, actually. But for a start, you can do both, of course.
All right.
Okay. But what I'm trying to say here is you should always write this out is to show the grader that you understand this formula is for Q2, for example. The bottom line is don't have a numerical value without it working, whether it's graphical or method or step working. Okay.
Oh, so I should memorize like the basic ones, like 180 minus alpha.
Yeah, that's why the previous lesson I had to keep on giving you the practice session, right? Like how to relate the basic angle across all 4 quadrants.
All right.
Okay, so when in doubt, always have the mental picture in mind. That's all. Okay, it's always this guy. Okay, understand? Then from here you will then solve for x. So a total of 5 possible answers. 5 possible answers. I'm not sure whether they all lie within the boundary, of course. Then you are supposed to solve for x across all 5 answers. Then you are supposed to check that (0 to 360 degrees. Get it now? Okay. So this is considered actually easy because you don't have negative quadrants. What Pavan did just now had negative quadrants, right? And that's always the most troublesome one. Worse still if you have negative quadrants involving radians. Okay. So it's just like running backwards on a track and field. Okay. So this is it for this kind of advanced equations. So next week I'll teach you all a little bit more to touch up the entire solving of trigo equation situation. That's where the applications part come in then. Okay. So today's session is recorded. I'll upload to the Google Drive after this session is